Hey, this is James Diamond, and in this particular video, we're going to be talking about the Glock CNC motors and tuning the driver to get the most out of it, and a few little tips in there. So the first thing I want to point out is that if you want to get the manuals and the hookup instructions, we don't print them out and include them in there. It's not everybody wants the paper, so we just kind of save on that, and we put the download on the website. And just under the menu item downloads, you will get the documentations right here. These are all PDFs that can be downloaded. Now, I will say that anywhere between when I'm producing this video right now and the next few weeks, we will be changing the website, so it will look different than this, but it will always be under a menu item of download. If you have any problems, you can go ahead and email me and I will get you the link to the appropriate download. Okay, so we're going to take a look at the 1200 watt motor driver manual. Now, actually that's a 1500 watt motor driver, but the motor itself is 1200 watt, but it has a 1500 watt capacity. Okay, let's go to that now that I gave you that useless piece of information. And we will look at the manual. There's a little bit of a quirk in the 1200 watt manual. The numbering on this is actually backward right here. This part is correct as far as how it's laid out on here, but for some reason the numbering is backward. It's a print problem, a print error. Okay, so we will start talking about top end speed and the difference between how you want it programmed inside the driver for manual speed control as compared to CNC control. There's a bit of a quirk in there. I'm not sure why it is, but it just kind of is under their how they build these. So if we look under the P111, and how to get to this part of the programming is right down here. And if it's a little confusing to you initially, that's okay. It was to me. You know, when I started doing this too, you just kind of keep doing it, you'll figure it out. So the first thing I'd recommend is before you change any parameters in here, write down whatever the value was when you opened this thing up and first got in that parameter setting. Write the parameter down in case you mess something up. You can go back and put it to whatever number it was when you got the motor. I suggest, unless you've really done something catastrophic somehow, that you don't set it to factory defaults, because the factory defaults aren't really the same as what it was when it was sent to you, or it's not even the same as what it is when the factory actually sends them to us, because they do some programming in there before it gets to us. So if you can avoid it, avoid doing a complete factory reset on it. I mean, it's not catastrophic. If you do, you'll have to go back and change more things. Okay, so let's talk about the speed rating right here, P111. Now, there's a difference in the voltage inputs. There was some of these that kind of slipped through that had what I would call the native 0 to 5 volt signal that controls the speed. But most of these, 95% of these, should be a 0 to 10 volt control, since that's what's most common in the CNC speed control world. If you happen to get a 5 volt, 0 to 5 volt one that I somehow didn't catch, or that's all we had, there's a resistors included with that, or I can point you to the right resistors. There's just 2 resistors that are put in a slot. There's an example on the download page. It's exactly how to do it. Super, super simple. That will take your 10 volt CNC signal and then just split it in half. No big deal, but I just wanted to make you aware of it ahead of time. Okay, so when you're tuning this, when it comes from me, typically this setting is going to be set at 5600. Okay, and that is generally the top speed of the motor. It can be anywhere from 5400 to 5700. It just kind of varies. Okay. That 0 to 10 volts is divided out equally among that range of 0 to 5600 RPM. Okay. Now, if you've noticed that once maybe you get to 9 volts that the motor is actually topped out, then what you'll want to do is lower that number down to maybe 5400, and you can get a better progression in there, or more precise progression. As you do that, you may lose a few hundred RPM off the top end, but you can dial in a more precise progression between 0 and 10, being 0 RPM and whatever the top RPM is. Now, you'll notice that when you're dealing with, if you're tuning servos, or you're tuning this motor, or you're even tuning a car, there's give and takes as you change different things performance wise, and this is really no different. Okay, now if you're going to be using this with the manual speed control knob, you want to double that number. It's just kind of the way it is, and this number, you would set this at, let's say, 10,200, and that will give you the full range of RPM with the control knob. Okay. All right, let's talk about P1, 9, and 10. These are exactly as it says in there. You probably won't have to fiddle with these at all because I will have them already set. The deceleration I usually have set to a high value. It might even be higher than what you see right here. Same with the acceleration. It's just because when I want the motor, if there's a load on the motor and it slows down RPM wise, I want the motor driver to respond as quickly as possible. And when you turn it off, or you turn off the enable setting on there, I want the motor to stop as quickly as possible as well. It's for safety, it's that way, and if you're going to be doing threading, then that's the way you'd want to have it too. Now these settings can only go so high before, they're not going to functionally be any higher, even though they can go between 1 and 60,000. Okay, so you can change those. You're not going to hurt anything. You're going to hurt anything changing those, but if you really want to, I suppose you can. All right, now just know ahead of time when I talk about the acceleration speed, this is going to be kind of a combination of acceleration speed and this P7 called the speed scale factor. I have allergies, so I'm going to itch my nose. Yeah, sorry about that. I guess you'll have to get used to it. So, okay. Some may notice, and you may notice this on any motor that you have, is that when you go to plunge in to put load on the motor, there might be a small lag between the time you put load on this and the time that motor says, okay, the driver says, okay, we've dropped some RPM, we need to send some more power through. Okay, so to minimize that, we can change the P17 setting. The P17 setting is actually kind of like the cam in a car. You can have a really mild cam, which makes the car run more easily at low RPMs, or you can have a more performance cam that might run kind of rough at low RPMs, but you're going to get a lot more torque under load, okay? More power. Now, when we send these out, they'll have kind of a general setting in there, and you'll adjust it to however you want. And this is actually, for those who have deep groove bearings, those actually turn a little bit harder than the angular contact bearings, so you probably won't even notice it because it's load under this automatically. But if you want more, what I would call a constant torque setting, so that you want as much torque going to your cutter as possible all the time, or you want as much torque going to on the lathe, going to the head as possible, so that when you go to plunge in to do a cut, that you have less chance of their slowing RPM down, then you'll want to set this to a higher number. And you can experiment with this to dial this into where you want. Now, again, you might lose some bottom RPM. So you might lose, let's say you normally would be around 200 or 300 RPM. Well, you might have to run everything at 400 or 500 RPM. Just because otherwise the motor will do one of these things. It'll be kind of, it's like an engine. If you have a high performance cam and an engine, you notice they kind of can almost like lunge a little bit. The motor does. Well, it's the same with the electric motor. When you raise this up, it's like putting a performance cam in there, and it's a little more notchy. But if you have load on it, you may never even notice that. It just depends on your setup. But just know, hopefully that didn't confuse you, but just know that this is the setting that you can change how much torque is going to that motor all the time. And the advantage again is that it has less of a chance of slowing down or slowing down very much when you go to put load on it, whether you're plunging into metal, lathe, mill, or what have you. Now, for those who have bought this motor for some other reason entirely, I have some people who buy these for centrifuges, all kinds of things. And you want to make sure that you have all of the range, including really low RPMs, and you're just not going to be putting much torque under it. Well, then you want to lower this number. and then you can experiment with that to figure out what number that you want in there. Okay, so hopefully that's helped you as far as tuning the motor to get the most out of it and where to get the information. Once again, this is James Diamond with GlockCNC, and I shall talk to you later.